Welcome. Question number 60. Locate centroid. See, sketch is given here. 60, 90, 25. One semicircle here. See, this is the given lamina. For this, you require centroid. This is center of the circle. That's all given. I should tell this one. If anywhere in this class, if you have difficulty to understand, go through what I told in the beginning of this class. Every class I am telling, now also I will tell. You are not serious. You have no dedication. You randomly came to the class, just thinking this as an entertainment video or video you are seeing in usual YouTube. You sometimes just click some video and enjoy it. This is not video, this is a class. And since you suddenly came, this is not for you. Start from beginning, systematically study, understand everything, make a note, improve your knowledge, then you will not bother. Those who are serious, they will look here and laugh. See, those who are serious and show dedication, they will look here. If anywhere in this class, if you have difficulty, they will tell no difficulty. I am understanding everything. You become one among them. Then the class is for you. Okay, start. See, Abelco, Eterco. I am not telling. What is Abelco, what is Eterco, now I am not telling. Each and every class, I cannot tell each and everything. I told earlier, if not this class, previous class or previous to previous class, Abelco is single dot. See, Abelco is single dot, green dot. Eterco is dot with the right. Okay, see, dot with right, green dot. That's all I can tell. Somebody will tell, arrogant person. No problem. People who know me, they know whether I am arrogant or student friendly. I am very, very student friendly. But people, those who don't show interest, for them, I behave harshly. Nothing can be done. I think I got the right to tell all these things. Okay, now 1, 2, 3, 4, I forgot now. I made a note of that one. See, divide into parts. 60, 90, rectangle. Semicircle of dia 120. So this is 60, full is 120. See, once this is 60, this also is 60, total 120. This is 60. Since this total is 120, this is 25, this is 60 here. See, this is 60. You can make a note of 60. It's actually not required. Okay, 60. I'm happy now? Okay, happy. From 60, subtract 25, you get 45. Vertically, this is 50. If this is 50, this will become 40. Total 90. Then this offset, I given 25. Okay. Over. Figure number, I will tell you. Actually, I can note down what I made there. See, 1, 2, 3. Okay. Coloring is not required. 1, which one is 2? 100%, this is 2. 1, 2, 3. See, G1, 50 is there, 90. Little down. G1, G2, G3. This is center of circle, O. Okay. Start. A1, A2, I will not explain. A3, pi by 8 of 120 square. You know what is this one. You know what is this one. Now, go for Abelco. When you go to Abelco, 60 by 2, 30. You should not write 30. You should write, show, you prepare a table, write there, what, part number, area in mm square, that is small a, x to right side or left side, depending upon Abelco or Eterco, from OY axis in millimeter. Then you show the calculation, half of 60, then you get 30, not copy 30. Figure number 2. 60 plus 1/3 of 45. 1/3, 60 plus 1/3 of 45 is, how it is 71.667? Oh, it's interchange, 1 minute. Oh, it's correct, 60. 71.667, how it is 71.667? 1 minute, 30, this is 45, 60, oh sorry, it is not 45, it is 35. Oh, see there, that's why I am not getting answer, 35. From 60, you subtract 25, you are getting 35 because 1/3 of 45 is 15. 15 plus 6 is 75. I was wondering how 71 point something came. Okay. 60 plus 1/3. See, if it is 35, then only area will become half into 35 into 40. That will become 700. Okay. 60 plus 1/3 of 35. This one. This way, midway. This way 2d by 3 pi. So exactly midway. See, center here, above the center, 60 or 120 by 2. Okay. X over Y. This is 90. See here, this is 90 means 90 by 2, 45. This one, 50 plus 2 by 3 of 40, 76.667. This one, 90 plus 2 into 120 divided by 3 pi. Yes, you will get X bar and Y bar. Or Aterco, start Aterco, X, 60 plus half of 60, 90, 2, 25 plus 2 by 3 of 35, 48.333. This one, directly 120 by 2, 60. Y, 60 plus half of 90, 105. 60 plus 1/3 of 40, 73.333. This one, 60, we want this distance, 60 minus 2 into 120 by 3 pi. You will get this X bar and this Y bar. See, these are the answer with this origin, this and this is the answer with this origin. Okay. Therefore, centroid G will be as shown in figure. Question number 60 over next 61. I will write and start. Today 4 questions, that's all. Question number 61. See, this is the lamina. Now, how to get the lamina? See, 160 base. This offset is 40. That is, this is, see, you should make a note. This is a quadrant of a circle which is actually removed. Or you can imagine, if you take full rectangle, this quadrant removed. This is not there. Then one semicircle here, center is here. Okay. All dimensions in millimeter. Make a note in the class. Now I won't waste time writing like earlier. See, earlier I used to write here, show the sketches for you, how division is made. That all you should do now. See, what you do is, you take a full rectangle, 160 base, 160 base, and height is 40 plus radius 60. See, if this is 60, this also 60. So 40 plus 60, total 100. So take a rectangle of 160 base and 100 height. 1, figure number 1. From that rectangle, this quadrant is removed, cut out. See, dark, 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 warning. In the formula, A1, total area is A1 minus A2 plus A3. x bar a1x1 minus a2x2 plus a3x3, y bar a1y1 minus a2y2 plus a3y3. Long back, one student told, sir, when you add all this one, you are not getting 17099.558. I told, not this question. I am getting it. No, sir. See, 16,000. Another 2,000, sir. Already crossed 18,000. But how it is 17,000, I don't understand. I told him, you better not understand. You better not understand. Then his neighbor told him in the Kannada language, hey, figure 2 is cut out. Kitta kirodu, removed. Nikal diya gaya. Then he told, oh, sorry, sir. So I should do A1 minus A2. Do it. Then you get the answer. Last time he was absent. He was absent for the class when I considered remote area. So he is telling, see, when you add all this, you are not getting. I told him, you better not get. Then he told, sorry, sir. Oh, don't tell sorry. Next time, don't be sorry. I told him. Instead of telling me sorry, next time, don't be sorry. Okay. Over. See, G1, figure number 1, figure 2, figure 3. G1, G2, G3. These all I am not writing. Dot right. This is your Abelco. This is Abelco, that is Eterco. Okay. Some will tell Abelco, Eterco what? My students will understand. That's all I want. Suddenly newcomer, in between who comes, he will tell, he is telling something Abelco, Eterco. Where is the term? He will go to dictionary and start at Google. I will tell him, go to Google. Google this word, Abelco, Eterco. You will get the answer there. Google it. Okay, start. A1, I will not, okay, I will tell 160 by 100, A1. Diameter 120, why 120? See, radius 60, diameter 120. So, pi by 16 of diameter square, pi by 8 of diameter square. See, this diameter is this 100 only. Okay. This is, if it is 100, this is 50 over. X, I am going for Abelco, half of 160, 80. For second figure, 2D by 3 pi, 2 into 120 by 3 pi. For this one, 160 plus 2 times of this diameter by 3 pi. Y, half of 100, slightly above this point. For this one, 100 minus 2D by 3 pi. This one, this way 2D by 3 pi, this way exact center 100 by 2. You will get X bar and Y bar with Abelco. With Abelco here, see, you will get X bar, Y bar. Go to Eterco. Area I am not writing. See, when I go to Eterco, area I am not writing. It will repeat. 1, X. 50 plus half of 160. 130. Figure 2. 210 minus 2D by 3 pi. Figure 3. 50, see, this distance you want. 50 minus 2D by 3 pi. Over. Y, half of 100. Directly 2D by 3 pi. Exactly center, half of 100. You will get this X bar, this Y bar. Okay, then X bar we got this side 112.263. See, this is total 160. Midpoint of 160 is 80, little more than 80, but before this one. Okay, Y bar we got with the which one? With the Abelco. With the Abelco we got 45.943. See, this is 40. So slightly above this junction. See, slightly above this junction. When you write the final answer, write the original sketch, but later make a note. Now only make a note. When you continue for moment of inertia, then instead of writing there, what you will do is, see, we will write it here. We will mark here and see. We will mark here and then we will write this distance and this distance. We will somewhere write this distance and this distance, and then we will go further for calculating moment of inertia at that time. But right now, question is, at that time, you write this one only, see, at that time 2 required. But if the question is only to locate centroid, write the original diagram here, tell centroid is here. Over. Question number 61 over 62. Okay. Prepare it. Question number 62. See here. 135 millimeter. This radius is 62.5. Then this will extend this side by 80 and come down by 50. This point comes. This is a given sketch. Make a note. Divide into 4 parts. One rectangle. See, one rectangle. Here 2 triangles. One triangle, 2 here, 3 here. Fourth one. See, this is not. See, this is 50. This total is how much? This total is 125. Don't see that side. See, that 125 is not here. It I have to mark later. See, this is 125 by diameter. When this is 125, this is 50, this will be 75. See, 50 here. Total 125. This is 75. So, this is not isosceles triangle. So, divide in 2 parts. If you get isosceles triangle, you need not divide. I will explain next question. Okay, 75, 50, over. This is 135. Height is 75 plus 50. Total is 125. No place right there. Little later, I will rub this one and write 125 here. Okay, I write now only. What is there? Not a big issue. I can manage here. Okay. How much this is? This is 50. Okay. This is 75. Right here, 75. Total is 125. Okay, done. It will neatly write here. 125 total. Over. Figure G1. See, centroid is midpoint 62.5. This is 75, little below. G2, G3, you know it. G4. A1. First, Abelco or Aterco, area same. 135 into 125, A1. A2, half base into height. A3, half base into height. A4, pi by 8 of diameter square. Okay. Areas are over. Total area you will get. Now go for Abelco. X. 2/3 of 80. Sorry, first just given here. When you put number 1 here, you start from there only. 1, G1. 80 plus half of 135. 2/3 of 80. Again 2/3 of 80. 80 plus 135 plus 2d by 3 pi. Y. 125 by 2. 2/3 of 75. 75 plus 1/3 of 50. Exact mid height, half of 125. You will get this x bar, this y bar. See, this is what I call this is Abelco. This is your Abelco. Okay, now start. Go for Aterco. When you go to Aterco, x 62.5 plus half of 135. 2. 62.5 plus 135 plus 1/3 of 80. Same for 3 also. Fourth one, 62.5 minus 2d by 3 pi. Y, half of 62.5. 50 plus 1 by 3 of 75. This 75 is not this 75. It came by calculation. You do one thing. You write 75.000. Okay. That means that 75 is not this 75. Okay, leave it. If you cannot understand that one, don't do the question. After I told so many times, never enter number, show the calculation. Still if you ignore and take 75, later think, oh, that is this 75. Then suffer, pay penalty. Next, this one, 2 by 3 of 50. Last fourth one, exact mid height, 62.5. You will get this x bar, this y bar. See now, x bar comes to from here, 151.288. See here, 80 plus half of 135 is 147.5. So it will be slightly after the midpoint of rectangle, this side. Then y bar you got from here, we were from Abelco, 63.244. See, this is 62.5. This also 62.5. So slightly above the center of rectangle. Slightly above. From there you know it. Centroid G here. Question number 62 over. Next number is question number 63. Actually, 63 is the last class. Last question for this class. 63. Interesting question. Question number 63, actually when lamina given, this division will not be given for you. See, the division they will not give. You have to divide it. See, because usually how lamina shown, it is shown like hatched this way. Okay, now, somewhere here, extra dimension given. See, here I will show 60, this also 60. 1 minute, I will just check the camera. I am coming to extreme left side. Okay, no problem. Okay, plenty of space is there. Okay, this is a question given. Now, make a note. How is the arrangement here? See, one triangle here. One quadrant of a circle, one quadrant of a circle. See, you can make out. That you have to imagine. Then, here, one semicircle is removed. That is, this is existing area. But neatly write. What we will do is, we will take, see, one full rectangle. Rectangle, figure number, okay. One full rectangle. Here. If you want, write here. Just to understand, A, B, C, D. Just time being one A, B, C, D. Later it will change, A, B, C, D. A, B, C, D is a full rectangle. To understand only, see, later remove it, A, B, C, D. Is a full rectangle. From rectangle, this is cut out. So therefore, see, dark, warning, cut out. Okay, then, one triangle here. One quadrant, one quadrant. Rectangle, I will take 1. This triangle, I will take 2. Now see, this is 60, 60. So this is isosceles triangle. If it is isosceles triangle, you need not divide into 2 parts. Single step you can do it. But still later, when you go to moment of inertia, there also, if it is isosceles triangle, no problem. There is formula for I about centroidal axis. It is depth base about the axis parallel to base is BH cube by 36. But about centroidal axis, perpendicular to the base, it is HB cube by 12 plus 12. 6. I will give later. Or those people who find difficulty later for moment of inertia, divide into 2 right angle triangle. Okay. If you want 2, you make 2 dash, 2 double dash if you want. So right now, single triangle. Then 1 rectangle, 2, 3, 4, 5. So actually ABCD is 1, 5 is removed. Now remove that ABCD. Because later some other ABCD is coming. Okay, this is the figure. Okay, remove this one. Okay, now start. Dimensions. This is 90. See, 90. This is 80. From here to here is 80. And this full given is 130. 130. Therefore, this will become, see, from 130 subtract 80, you get 50. Now, make a note. This 50 is also radius of this quadrant. Therefore, diameter is 100. See, diameter 100. See, this is 50, this is 50. Both are equal. Everything is equal. So, make a note. Diameter 100. Why 100? 130 minus 80 is 50. See, this is, oh, something. See. Okay. This way it is. I was wondering what happened suddenly. Okay. Sometime it happens. Okay, no problem. Diameter equal to 100. Okay, now done. This is 1, 2, 3, 4. Okay, no problem. 4 and 5. Okay, now correct. Suddenly, I can make out because, see, shape is here. I did not observe it. Okay, now. So, 1 is the rectangle, 130 by 120. How 120? 60 plus 60. See, don't see this side. This is separate. 60 plus 60 is 120. See, 120. And for the semicircle, diameter is 120. So, this will be 60. Why? Half the diameter, radius. So, this is 130 means center is 130 by 2 is 65. So, the semicircle will come almost up to here. Little gap will be there, out of scale, over. I think this much you can understand now. Now, how I got 220? 120, see, if this is 50, this also 50, radius. 50 here, same projection, 50 here, 50 here. 50 plus 60 plus 60 plus 50 is 100 plus 120, 220. Full base is 130 plus 90 is 220. Oh, both are equal. It is a coincidence. Both are equal is a coincidence. 1 minute. Correct? It's only coincidence. 155 plus 65. Okay, no problem. Just coincidence. Correct? Okay. Now, G1, G2, see, this isosceles triangle, centroid is exactly here. This way 1/3, this way 2/3, this way exactly mid-height. This is all I told for you. See, isosceles triangle. This way midpoint, 2d by 3 pi, 2d by 3 pi. Here also, G4, 2d by 3 pi, 2d by 3 pi. This is 2d by 3 pi. This is 5, dangerous, removed. So, total area is A1 plus A2 plus A1 plus A2 plus A3 plus A4 minus A5. X bar is A1 x1, A2 x2, A3 x3 plus A4 x4 minus A5 x5. That remember. Now, before you start, observe something. This looks very good. See, like an aeroplane. See, it goes like aeroplane. This question actually given in one of the examinations. I saw it. Actually, what I do is sometimes I refer some old question paper. Some papers are there with me, very old. If I find something shape, that's all. Dimensions, I will decide. Okay. Now, see here. Correctly observe. 60, 70. Oh, before you start solving, right here, there is axis of symmetry. You write the sketch once again. See, once again prepare a rough sketch. Like this, you prepare a rough sketch first. And then in that rough sketch you write here. See, not here, somewhere here. This is axis of symmetry. See here. You write here. This is axis of symmetry. Therefore, there is no need of doing y bar. See, exactly mid-height. How much from here how much from here? Total overall is 220. Therefore, you can make a note there. From here to here will be 220 by 2. From here to here also will be 220 by 2. You make a note, not here, somewhere here make a note. Okay, now I'll remove it now. Therefore, write after that sketch here, rough sketch, you write what? Y bar, you make a note here. Y bar not required, but X bar is required. So you have to find only X bar. See, to find only X bar. Okay, start. This time original not required. See now, first solution 1, your options. See, you have two options now. One option is take reference axis here. Okay, I will call this as AB. From AB, take X this way. This is your X from no able co now. One is X from AB this way. After completing solution, after everything is over, you write the sketch once again. There you write, see, you take reference axis here. Say CD. CD, take X bar this way. You should not rub it out like that. First time when you solve, you mark AB here and X bar this way. Complete the question. Get the X bar answer. Go for location of centroid. When everything is over, write alternate solution. Take CD reference here. Now I am removing here. See, I am removing. That much you can, like one Eterco, I forgot it. One Elerco, one Eterco. One left side, one right side. Okay, start. Figure 1, area 130 by 120. Figure 2, area half into base. Base is here. See, this full triangle base is here. 120 into 90. Figure 3, pi by 16 of diameter square. Figure 4, same as figure 3. Figure 5, pi by, see, figure 5 is dangerous. Pi by 8 of 120 square. Total area will come A1 plus A2 plus A3 plus A4 minus A5. Now start. X distance. Centroid here. See. Here, X1. 90, this full is 130. See, 130. 90 plus 130 by 2. 155. Figure 2. This is 1/3. This is 2/3. 2/3 of 90. 60. Figure 3. From here, 90, see, from here you want. I already told AB is here. AB is here. This is your AB. Okay, so maintain AB here, time being. When I explain, don't see that one, AB. 90 plus 2D by 3 pi. Figure 4, same. Again 90 plus 2D by 3 pi. Figure 5, 90 plus 130, that is 220 minus 2D by 3 pi. Calculate X bar. X bar will come 107.860. Okay, X bar will come from left side. See, if you refer from this line, don't write axisymmetry now. Now final answer. If you refer from this line, your X bar is 107.860. 107.860 means 90 plus little more. 90 plus another 17 more. So this is how much? This is 50. So maybe here, see. This distance is 107.860. Then from the total length of 220, subtract this distance, you will get this distance. 112 point out of scale 140 over. And this is axis of symmetry. So directly right here, this distance up to extreme end here. See, this up to extreme end here, and here also AB is not required, no? Okay, AB, okay. Up to extreme end. Both of them are total 220. So 110 and 110. This is this side. Okay. This is centroid for the given sketch. Only X bar required. Complete the question. Once you complete the question, then for understanding purpose, you take reference line CD here, and take X this side. See here, answer. X1, half of 130. X2, 130 plus 1 by 3 of 90. X3, 130 minus 2d by 3 pi. Same X4, 130 minus 2d by 3 pi. X5 is 2d by 3 pi. Your Y X bar will come 112.140. Then you do one thing. See, from here, CD, first you get, this is your X bar you got from this side. How much you got? 112.140. From total 220 subtract, get 107, 110, 110. This is centroid for the given lamina. Okay. And remember, later when you go to moment of inertia, make a note here. What we will do is, see, this is, we will draw here, not there. Instead of marking there, we will mark it here. Because this is from here to here is, how much it is? 111, 107, little earlier. And then this way we will mark centroid. Then I will go for moment of inertia calculation. BDQ by 12 plus pi d power 4, etc. BHQ by 36, etc. IG plus A square, parallax theorem. We will continue in moment of inertia. At that time I will do one thing. When I give this question for moment of inertia, I will give the sketch and write for the given lamina, find moment of inertia about centroidal axis. Then I will tell just like that. Refer old class number I won't tell. Search for the old class. Good. You should have made a note in your book. Or maybe I will tell you, an old question is 63, but then question is different. You will get X bar equal to 107.860 from left side, or you will get 112.140 from right side. So locate here. Now YY is, see, this is symmetrical axis here. I will call this as XX axis, this as YY, and then I will write start. Now moment of inertia calculation. At that time I will do it. Maybe at that time moment of inertia also is exercise for you. Why? By that time I would have explained so many questions earlier. When the time for exercise comes, I will give. So later this exercise you continue for moment of inertia. Answer will be given for you. Maybe briefly I will write somewhere here, something etc., something plus etc. Number I will write. So then I will briefly explain so that you get little better idea. Okay. Question number 63 over. Today 4 questions. Sunday I had a marathon class today for around 5 o'clock up to 9:30. Little felt tired. I took some rest. Then I started now this recording. See, each record, this total recording, I think will be around 45-50 minutes. But to write everything all, see, just now I came and talked for 50 minutes most probably. But I took nearly 20-25 minutes to make all this entry neatly. So even though you see record total duration, maybe 40-50 minutes, I may require writing time all, I require around 2 hours. It is actually more than midnight, 3 o'clock now. Again, you should remember, this much I am trying. Why? This much effort I am putting. Why? If you think that way, you will be serious. Okay. Thank you. We'll meet in the next class. Question number 63 over 64. Next 64. See, next class also, this statement will be there. I may change it. Because in between I got other classes. Other classes are there. Then I had rubbed the board. So I can't maintain. That's why next class, this I will write. If anywhere in this class, if you have difficulty, I may write next. Next time I may write. If you have any difficulty, you stop continuing my classes. I may write that way. Someone may tell, very arrogant person. Okay. People, those who know me, they will not tell. This much I am struggling to give you complete education in structural engineering. Okay, thank you.